Okay, as Vian rightly said, this is one of the longer projects that's been going on, and it's actually diversified into many more physiological aspects. In my previous talk, I told you and I explained how complex dormancy progression is. With this next talk, I want to show you or overlay the complexity of physiology within the dormancy progression. A very, very recent article, May this year, some of our French researchers published this article showing in this diagram the complexity, all the known physiological interactions with dormancy maintenance. And it's not surprising here to see aspects such as hormones, sucrose and lipid metabolism, oxidative stress, transport capacity, all of these physiological systems interacting with dormancy maintenance. They also show the importance or the interaction of low temperatures. These little snowflakes indicate where low temperatures come into play, and the red indicate where rest-breaking agents come into play. So this makes very comprehensive research, but what I want to bring across is the complexity of this, that all of this is interlinked. And it's quite challenging to do research in a platform that is so interlinked. But we did attempt this, and where our research fits in is we have got aims and projects on respiration, which would fit in there into their diagram. Lipids, mainly lipids belonging to membranes and membrane differences, and also looking at hormones, specifically ABA. So those are our aims. What did we do? We've collected material from, again, a warm and a cold area, so that we have these contrasting conditions. Crips pink terminal buds, and we collected them all through the winter area, so that we have samples representing our dormancy progression. And then we continued our sampling into the application of rest-breaking agent, also to see the effect of Dormex and oil on these physiological aspects. To do that, we had to bag up, that's what you see in that picture, we had to bag up some of the shoots prior to dormancy application, and that is kind of an image of what it looks like in the field. Then we would take the buds into the lab and subject them to various analytical procedures that I'm not going to go into in detail. But what I can mention is, for respiration, we didn't just look at total respiration, we looked at individual respiration pathways. When we investigate respiration, for lipids, we look at neutral and polar lipids. For hormones, we are mainly interested in ABA and ABA metabolism in the buds. If we look at some of the results, I will show you just results from respiration, but I'll try and summarize the rest as well. Again, dormancy progression through the season, and on this axis we have total respiration rate. If you follow the dotted line, which is the Koa-Bokkeveld, you can clearly see that respiration decreases during the winter, and this is no surprise. As you have growth inhibition, you have a lower need for energy production, so therefore lower respiration. It hits rock bottom here somewhere in the middle of July, and then, importantly, very sharp increase in respiration as it's preparing itself for high energy growth happening during bud break. If you look at the algin, the warm condition shoots, you see a different performance. You see the decrease, the solid line, and you do see a turnaround into an increase. But the respiration levels never reach or are never restored to the high levels. They seem to be meandering around and never shoot up as high as they used to be prior to the season. And this could possibly mean that there's less energy available for those shoots to actually perform during bud break. If we look at the same situation during Dormex application, we can look at respiration of our control, which will not have received Dormex. So without Dormex, the solid line, we do see some changes and an increase, but it is a much weaker respiration rate compared to the Dormex buds, where you have a very strong increase in respiration. So what this shows you is that Dormex and oil treatment, the rest-breaking agent, tries to do very similar to what coal does by increasing the respiration. I need to summarize, Vian. There you go, the respiration I've just spoken about. Lipids, we've seen cold areas showing higher double bonds, more fluidity. Again, Dormex compromising or trying to rectify the situation. Hormones, very interesting results that's still currently being investigated. We actually found higher ABA levels in the warm area, but an incomplete metabolism of ABA in a warm area. Why is this important? I just want to end off with that. It always sounds that it's very physiological. Why does that matter from a day-to-day apple-producing farmer? Why would that be important? Understanding the complex physiology really helps us researchers to take a targeted approach in research, that we use a sniper rifle instead of a shotgun when we try and design new rest-breaking agents or just horticultural practices that could help us face these challenges of warm winter conditions. Thanks.